Hello there, ladies and gentlemen. It's George from LimeChain, and this is a special edition of the Blockchain Developer Weekly Digest. This is a new show that I'm planning on, and it is the Blockchain Developer Review. And in this edition, by popular demand, I will be doing a screen review of Moloch DAO. I will go through the code, I will share my experiences and my thoughts over Moloch. So without any further ado, let's straight dive into Moloch.
Okay, guys, let's get straight dive into Moloch and what actually Moloch is and what is it all about. So Moloch is pretty much an attempt to decentralize the way that funds are distributed in the Ethereum community. What this means is that this is pretty much a reincarnation of the old DAO, pretty much the DAO. That's the reason that now Ethereum Classic and Ethereum or like current traditional Ethereum exist, and it is pretty much democratizing the way that funds are distributed in terms of grant, etc., etc. Moloch is a decentralized autonomous organization, which means that all of this DAO is based on proposals and votings, and based on shares. And who is behind Moloch? Well, because it's DAO, it's pretty much no one is behind it, and everyone is behind it. It's the community that's behind it. The creator of this DAO is Amin Soleimani, the CEO of SpankChain and one of the most active members of the Ethereum community, also one of the most active developers in the community. And the DAO Moloch operates on the premise of submission of proposals, voting on these proposals, and there is a native asset called share token, the shares, and you are receiving tokens, or any member is receiving such shares in exchange for their contribution to the Moloch. Currently, there are 6,000 shares, and share worth is pretty much 266. And there are 1.5 million in the guild bank, which is pretty much the trésor of the Moloch. What I'm going to be reviewing this time is the way that smart contracts are written. I'm also going to give you a couple of my thoughts on the Moloch and an interesting opportunity that I have tried to capitalize on. So let's start with the repository, and the repository is GitHub Moloch Ventures Moloch. This is a repository of a genuine truffle project. As you can see, there is truffle config, there is truffle.js, contracts, tests. There are like 1,200 lines of code in the tests. I'm not going to go through them, but what I'm going to go through here are the contracts. Let's see what's in the contract folder. There are some common OpenZeppelin files, OpenZeppelin audited contracts, ERC20, the interface to it, ownable, and safe math. The three most important contracts for Moloch are the token. Let's go through inside. Well, as you can see, it's a regular ERC20 and the guild bank, which I'm going to talk a little bit later about, and the Moloch, which is the general file for the Moloch DAO. So there is also a README that has a very nice explanation of what to look for and what are the general concepts. I pretty much gave you the overview of what the general concepts are, but going through it, there are a couple of things that you need to know that are written in here. As stated here, Moloch operates through the submission, voting on, and processing of series of membership proposals. Anyone that wants to become a member needs to find an existing member and ask them to submit proposal in order to include them into the Moloch DAO. Anyone that is submitting proposal are also required to deposit 10 ETH that is returned back regardless of whether this member is put inside the DAO, whether it becomes a member or not. And the how many ETH and how many shares are pretty much given back, and how many ETH is inputted by the applicant is pretty much decision on the applicant. You can normally it's a one-to-one relation for regular members, but if you want to request a grant, you can say, hey, I want to not be inputting any ETH, but I want to just be receiving back shares that I can then sell, and I'm going to use the money to finance my operations for something that is for the thing that I'm proposing. Let's say this is development of application, development of a tool, something that the DAO members have decided that is worthy. On the opposite side, you can offer more than one ETH per share. This is when you want to incentivize more the members to give you these shares. Let's say that you're a controversial figure and you want to make sure to pretty much buy your way into the Moloch. You can do so too. There are two periods of voting. So period, what is a period actually? Well, period is 4.8 hours, which means that there are 5 periods per day. So there can be only one proposal started per period, which means that there can be only one proposal ending per period. And one proposal typically lasts 14 days. The first 7 days are called voting periods. During the voting period, any member can vote with their shares. The next 7 days are called the grace periods, and the grace period is the time where the members that have voted against certain proposals that have passed, or the members that have opted to abstain from voting and decided not to vote can rage quit. And rage quitting is very interesting term that is part of the Moloch, which this means I'm withdrawing my stake into the Moloch in accordance with the shares that I have. Pretty much this means that if a proposal that you dislike, a member that you dislike, or operation that you dislike is approved, and you can rage quit and take back your stake of the Moloch. And last but not least, something that we're going to review a little bit later, there is 0.1 ETH reward that is deducted from the proposal deposit and is sent to the account that calls process proposal. As you will see a little bit later, process proposal is the function that somebody, it's not said who, anyone pretty much can call in order to process and do the internal accounting for a given proposal. So with this specific in mind, let's get into the Moloch Solidity code. Moloch is pretty much written by Amin. As I said, I highly regard him as one of the top Solidity developers out there. Moloch is written in 0.5.3 version of Solidity. And without going into the what kind of fields are there in the Moloch, I'm going to go into the constructor, because we're going to go to a good portion of the fields of the contract just by looking into the constructor. So what are the parameters of the constructor? Well, first of all, there is the summoner, which is pretty much the first member that is there. Remember, in order for somebody to become a member, in order for a proposal to be submitted, there needs to be another member that is going to deposit 10 ETH in order for a certain proposal to go through. So this is the first original member that is getting into the Moloch without any proposal. Probably this has been Amin. Approved token, this is a little bit of ambiguous name, but this is the token that is going to be used for paying the proposal fee, the fee that you are going to pay in order to get shares. So this is a ERC20. In the current mainnet version of Moloch, this is wrapped ETH. Period duration, as we said as we read in the README file, is 4.8 hours. written in seconds, so it's 7280. So this means 4.8 hours or 5 periods per day. This is the default value that has been passed. Voting period is 7 days. Grace periods are 7 days. Abort window is very interesting. Key is pretty much a time frame in which the applicant, the person that somebody is submitting proposal for them to become a member, can opt to abort this proposal. So let's see what are the default values for these three fields. So voting period is 7 days, grace period are 7 days, and abort window is 5 periods, which means 1 day. Going through the next piece of parameters, there is the proposal deposit, duration bound, and processing reward. So proposal deposit states how much you need to deposit in order for you to submit a proposal. This is pretty much in order to avoid spam. There is around 2,000 $500 that you need to deposit when you're proposing stuff. You're going to be returned this minus the processing reward, and processing reward currently is 0.18. So we're going to speak about the processing reward a little bit later when we go through the process proposal function. So as you can see, proposal deposit is 10 ETH. Dilution bound is something that is very interesting. This is the multiplier, the maximum multiplier this is a bound that says, hey, if this proposal goes through, are the shares that are in this DAO going to be more than the dilution bound times? In this case, if this proposal goes through, are we going to have more than 3 times more votes? This is considered high dilution, and as you can see, we will see in the functions below, this is going to mean that this proposal cannot go through. So the current number is 3. So you cannot submit proposals that are going to print more than 3 times more shares than what currently there are existing in the DAO. So pretty much these are the things that are inside the constructor. What the constructor does, it saves the token wrapped it creates a guild bank. I'll tell you a little bit later about it. It sets all the different fields. It says the summoning time is now. This is used in order to calculate when the periods start. The first member is created, and with 1 share, as you can see, the total share is now 1, and an event is emitted. So interesting thing is what is the structure member and what are members and member address by delegate key. In order to answer this, let's go and look through the structure called member. And member is a very simple structure. It has 4 fields. First field is delegate key. Key is a little bit misleading here, but pretty much this is the address that this member is going to be using in order to submit proposal or vote on proposals. Shares is how much shares this member has in order to vote for certain proposal. This boolean exists, is used in order to figure out whether this member has been created. So if this is false, this means that this member has not yet been created. And highest index yes vote means the last proposal, the latest proposal that this member has voted yes for. This is going to be important later when we review rage quitting or withdrawing your money. And what are the 2 mappings? What are members and member addresses by delegate key? So members is pretty much mapping between address and members. So you're going to be finding the member based on based on address, normally by message sender, and member address by delegate key. So you're going to be finding the address of the delegate key by certain message sender. Last thing that is important is the proposal structure and the proposal queue. So proposal queue is pretty much an array of all proposals that are there, and one proposal contains all these fields. I'm going to briefly go through. So there is a proposal and there is an applicant. So the proposal is an existing member that has submitted the proposal. Applicant is the member that is getting into, or at least the address that is going to be receiving back the shares if this proposal goes through. Shares requested and starting period are pretty obvious, but this is how much shares you are requesting for the tokens that you're going to be tributing in. So there is another field here that is token tribute. Starting period is when this proposal is going to be started, and voting is going to be started, which means that the 7 days are going to be started to be counted. How many yes votes have been there, how many no votes has been there, whether this proposal has actually been finalized, called proposed, and if it's been whether it's been proposed, whether this passed successfully or not, whether this proposal has been aborted by the applicant, and some details. This can be an IPFS hash as it has here, it can be a plain text, it can be just a JSON, you can pretty much write anything that you want there as a proposer. Last two fields, max total shares at yes vote. This is again used for internal accounting, how many shares are going to be if there is a yes vote. Remember the dilution bound. This is going to play interesting part as you are going to the submit proposal method, and votes by member, obviously what a given member has voted. So with these things in mind, let's start going through this contract, but something that I remembered, let's look at the guild bank. As you can see here, when we are creating Moloch, we are also creating a new guild bank. If you look at the guild bank is very simple smart contract. It's important to be seen that this is ownable. This means that the owner of this guild bank is actually the Moloch. This means that the Moloch DAO can call withdraw and can say, hey, I want this receiver to receive the amount that they're owed by the shares that they want to burn, and these are how many all the shares are. This is going to be used, you're going to see it used when we are reviewing the rage quit function. And there are like some checks that are there, but pretty much this line here says this is how much you're going to be owed for rage quitting for this amount of shares. And as you can see, you returned this amount of tokens, this portion of tokens based on all tokens back. As I say again, in Moloch we are talking about wrap ETH. So now let's get started and let's go into the different functions. So there are like a couple of interesting functions. First of all, through the life cycle, it is the submit proposal. So submit proposal can only be called by a member and or delegate of members. So this is why you can see here only delegate modifier. Let's look at this modifier. So only delegate means that this is a delegate address of a member. As you remember, we spoke about delegate key. There is another modifier, only member, that we're going to see a little bit later. So only delegate can call this submit proposal, and it can be called with applicant who is going to be receiving these tokens, how many tokens are they going to submit, which means how many wrapped ether they're going to submit, how many shares they're requesting for all of this, and some details. If we look through the logic, there are standard sanity logic, whether applicant is different than 0, there needs to be less than the max number of shares after the shares requested are added. Total share requested is an internal counting variable saying, hey, how much are going to be the shares after all different proposals go through. So we need to make sure that this is under the value that we have set for the limit of shares the Moloch can have. and we're getting the member address for this message sender, and we are getting the deposit. So we are getting the proposal deposit from this member, and we are getting the token tribute from the applicant. So if I have said I want to input 100 wrapped ETH in order to receive 100 shares, this tribute is going to be taken from my account. Then we need to figure out what is the starting period. Of course, here is the logic of, hey, if there is, what is the bigger? The current period that is going on, or the last untaken period that is out there. So pretty much this says, if this period is not occupied, use this. If not, use the next available period. And we are creating a proposal with the member address of the proposer, the applicant, how many shares are requested. When all of this is started, of course, there are no votes yet. It has not been proposed. It has not passed. It has not aborted. This is how many tokens I have. I'm pledging to Moloch. These are the details, and max total shares at yes vote. So let's see, and then this is all proposed for the queue, pushed in the proposals queue, and the proposal index is seen by the length of the queue -1, obviously, and event is emitted. So as you can see, the proposal creation is kind of easy. A couple of things that you need to be aware of. All like these two, token tribute and share requested, are pretty much two parameters that you can use in order to differentiate between different type of proposals. You can have a membership proposal where you can have one-to-one relation between the token tribute and the shares requested. You can have more tokens distributed than share requested if you're a controversial figure, or you can have more shares requested than tokens distributed, and the tokens distributed can actually even be 0 when you are requesting a grant from the Moloch in order for you to develop something that is going to be described in the details. So after proposal is submitted, well, now it comes to the voting. So voting can only start after the starting period has gone through. Again, voting can only be done by delegates, by members, and pretty much there again, beginning of this mid-vote function is just regular grooming, whether this is a real proposal, etc., etc. And we are getting the proposal. We are requiring that nobody has voted, or nothing special has been passed as vote. And again, as I said, the voting period needs to have started, but we need to be specifically in the voting period. So these two requires say, hey, this is now is after the starting period, but before the grace period. This member that is voting, the delegate for this message sender, need to not have voted, which means the vote needs to be null, and the vote needs to be either yes or no. So you cannot be voting with null again, and the proposal needs to not be aborted. If all these conditions pass, well, we can store the vote. In the proposal, we can say, hey, the vote by this member is whatever they have voted. If the vote is yes, we need to do a little bit more grooming. So we need to add the yes votes. We need to also store for this member the highest index of yes votes. And because the proposals are processed sequentially, well, the current proposal is going to be the highest yes vote. However, there is also this check whether you are not voting on some previous proposal in order to be sure to not to overwrite with a lower proposal index. So pretty much the highest index is set. Most of the time, this is going to be the latest index of proposal. for the highest yes vote. This is going to be important when it comes to rage quitting. Total shares are checked whether these the total shares are more than the proposal max total shares at yes votes, and then the max total shares are set to the total shares. This means that the max how many are the maximum shares that you're going to get at yes votes is determined here. And if the vote is no, well, you're going to pretty much, you're just adding more to the no votes. As you can see, voting is always with all the shares of given member that is voting, and then you're submitting the vote. So all of this happens, as I said, during the voting period. After the voting period, there comes the grace period. Grace period can be used for rage quitting. So many times I told you, hey, this is going to be important when it comes um, to to rage quitting. So let's see what's going on with this rage quitting. So the rage quit function, let's go through it. Rage quit function says, hey, I want to be rage quitting for this much shares of mine, normally all of them. And there are a couple of checks there. First of all, whether you have enough shares to be burned, and then whether you can rage quit. And there are a couple of requirements in order for you to be eligible for a rage quit. So let's see, what are these? Well, in order for you to rage quit, first of all, you need to for the last proposal that you have voted yes to be processed. And pretty much this is it. But this means that you can rage quit on proposals that you have voted no on, or you have not voted at all. So after we have determined whether you're eligible for rage quitting, well, we're burning some shares, we are reducing the total shares, and then we are doing guild bank withdrawal. This is why I told you it's very important that the guild bank is created in the constructor of the Moloch DAO. And then you're receiving back through the guild bank withdrawal function that we already saw, you're receiving back your wrapped ether. So this is what the rage quit is. And this can be done during the grace period or later. So after the grace period has passed, you or anyone else actually can call the process proposal. This is the grooming function of the proposal. This is where the proposal is being groomed. So let's see what needs to be happening here. And of course, I need to remind you that there is actually a very interesting incentive for somebody to call proposal, because you're getting 0.1 ETH as reward. And process proposal. Well, first of all, you need to do the checks whether this is a valid proposal, whether this proposal has passed the grace period, which means it's eligible to be processed, whether this has been whether this has not been processed already. And yeah, after all these checks are true, then you can mark this proposal as processed, and then you need to do some grooming in terms of shares. So total shares requested, the variable that is used in order to count how many shares are out there put into proposals that have not gone through, is pretty much lowered with how many shares are given. And if all of these did pass, which means that the yes votes are more than the no votes, and again, this comes back to the dilution bound. If the total shares multiplied by the dilution bound are less than how many the total shares at yes votes are going to be, which means that how many total shares that are going to be is if this proposal goes through is more than 3 times the current total shares, well, we say this is a failed proposal. So this is the check that says, hey, we don't want to dilute too much the share of the Moloch. So if all of these did pass, or let's first review what happens if this has failed or been aborted. Well, pretty much the applicant are returned their token tribute. If, however, this proposal did pass and it hasn't been aborted, well, we say, hey, this proposal did pass, and we do some grooming in terms of creating a new member. If this member exists, we pretty much add them some shares. If the member does not exist, we check whether this applicant exists with a different delegate key, and if this member exists with different delegate key, it's reset to their key. And last but not least, if this member does not exist, then the new member is created with the proposed shares, and then pretty much the proposed shares are later minted. So as you can see, this is the total shares are added. The shares that are given to this member are added to the total shares, and the guild bank receives the wrapped ETH. So after this, as you can see, the message sender, the person that has triggered this function, this grooming function, is given the processing reward. So again, this can be triggered by anyone, and the deposit is returned back to the proposer. So pretty much this is how processing goes through. One last important function, or actually two important functions, are update delegate key. This is pretty straightforward. This can only be called by a member in order to say, hey, I want to be represented by this address. This is everything that you expect it to be. The new delegate key should not be 0. It should not be the same as the message sender. And of course, then this member is now assigned, like this delegate key is now pointing to the message sender, and this member's delegate key is now the delegate key that has been passed. And abort function, as I told you, this can only be triggered during the abort window, and if the abort is triggered, pretty much the applicants are returned back the tokens to be aborted. But as you can see, the deposit is not immediately returned to the proposer. This is the proposer. These are returned to the to the proposer later when the process proposal is called. So this is everything that there is in the Moloch DAO. I think it's very, very well written. So couple of interesting things. Let's see what we have in the ether scan for the Moloch. This is the address of the Moloch, and I have to admit here that I've been guilty of pretty much milking the Moloch because there have been something that I call the wars of processing proposals. And as I told you previously, there is no limit to who can call the process proposal. So pretty much I am mining the Moloch, doing the duty of processing proposals, and getting back some rewards from the Moloch DAO for the processing of these proposals. So yeah, and again, I'm going to show you the code that I'm using there. The interesting part is that there is actually some other people that are doing the same thing. They're actually trying and front running what I'm doing here. So I have been getting into very interesting front running and processing proposal wars. So yeah, let's get a little bit of look of my milking script for Moloch. All right, as you can see, I have written my scripts, my Moloch processor in Go. Truth be told, this is not the most beautiful code that is out there, but obviously this is for my internal usage, and I didn't need it to be super fancy. So first thing that I have done, I have converted the ABI into a Go contract. So this is done pretty much very easy. And the important thing is this main Go and the Moloch processor Go. So Moloch processor is pretty much my general Moloch processing logic. And I have created one function called watch and process, which pretty much I have inputted initial gas. So what is the idea here? Because I was fighting frontrunner, which was waiting for my transactions to go through and was inputting them with a little bit more gas, I've decided to do override transactions, several override transactions, counting that this frontrunner is actually haven't been smart enough to use one and the same nonce for same front running. Hopefully they're not listening to this video, but I don't care if they are. It has been a very interesting war of milking the Moloch. I know this is not the most optimal way to fight frontrunners. However, I don't care. It got working for me. So what I've been doing here, well, pretty much I have been looking for in the proposal queue for the latest proposal that is going to be coming up. As you can see here, I'm getting voting period length, grace period length, what is the current period, and what is the queue length. And then I'm going through the queue until I find the next not processed proposal. And then I am doing some mathematics in order to find when the end period is. And if the end period is to more than one period away, well, I pretty much am saying, hey, there is nothing to claim. Actually, if the end period has not passed, I'm saying nothing to claim. I'll show you a little bit later what I'm doing in terms of waiting for periods to come. If, however, there is a period that there is proposal that has not been processed and they're eligible to be processed, well, then I'm getting nonce, and I'm sending actually 7 transactions that are each double the gas price and same gas with the same nonce. And I'm counting that this front runner is actually going to pick up some of my previous transactions that are not going to go through, and they're going to release them with a little bit more gas than my lower gas transactions, which means that most probably are going to get stuck in the mempool of the nodes. So I'm counting on my latest transaction to go through. Then I wait for my latest transaction to go through, and then I see whether I have been able to claim everything. So sometimes this works, sometimes it doesn't, but hey, I'm good with all of this. So I promised you that I was going to tell you, hey, this is where when I'm doing how I am waiting for the different periods. So when I say watch and process, when I call the function watch and process, I'm returning myself amongst other things how many periods difference there is between what current period is and when the next proposal is ending. If there is more than one period, I'm actually doing a long period of sleeping, which is pretty much one period. And if there is just one period, I'm now wrapping up my activity and I'm doing a shorter period of waiting. And pretty much this is what my processor does. And what are the results? Well, pretty much these are the results that we're seeing. As you can see, sometimes it is me that I'm getting some problems. I'm getting front run by other people. Other times I am front running other people. As you can see, I have ramped up by sending of my transactions that even sometimes more than one of my transaction goes through. But it doesn't matter because most of the times it's just like a couple of cents to send transaction, whereas I'm receiving 0.1 ETH, which is around $20, so it's well worth it there. I'm very thankful for being able to write this script because I was able to understand how Moloch works. And hopefully through this, I've been able to show you how actually Moloch works too. One last thing, my general thoughts about Moloch. Well, I think Moloch is super cool concept. I think this is the place where the grant system needs to go. I'm personally a fan of this. Whether Moloch is going to succeed or not, I'm not entirely sure. I see some problems with Moloch. For example, as you can see, there are like 6,000 shares that are there. But if we look into latest proposals, you're going to see completed proposals. You're going to see there are actually Vitalik has 1,000 shares, and Ethereum Foundation, which pretty much is Vitalik represents Ethereum Foundation. Ethereum Foundation represents Vitalik to some extent. They have 10 proposals, 100 tokens, 100 shares each. This means that Ethereum Foundation and Vitalik has 2,000 of the 6,000 votes. In addition to this, you can see that there is actually consensus and Joe Lubin. So Joe Lubin has 1,000 votes, and there are like 1, 2, 3 people, and there are 4, and in voting there are 2 more, so there are 6 people from consensus for 100 votes each, and thousands for Joe. So consensus pretty much is represented by 1,600 votes, and this means that Vitalik Ethereum Foundation and consensus with Joseph Lubin have 3,600 of all votes, which, if we go back to how many are there, actually this is more than half of the votes. If we go 3,600 divided by 6,115, you can see that actually 60% of the votes are pretty much are controlled by 2 groups, which pretty much means that if these 2 groups decide to go together and not to let any other member go inside, or not to decide for to pretty much add whoever they want, they can do it because they have 60% of the votes. So I don't know how all of this works, but for me this is risky, is susceptible to work. But I guess that if pretty much we're on their grace to not do so until we get more than 70 to 100 votes, where they're no longer going to be majority, but for this time being, they're the majority. And this is why I have no problem milking Moloch, although I think milking is beneficial for everyone else. And pretty much this concludes my overview of Moloch. Thank you for staying 40 minutes with me reviewing Moloch, and I hope that you have learned something and you're going to experiment more with Moloch. You can create your own DAOs by forking Moloch. I think it's a great idea to do so. Thank you very much. You can follow me on Twitter at gspasov, and I hope to see you soon, guys. Bye.